So good evening, sir. This is the second problem sample of my uh, module 2 in Newton's law of motion. So now the problem here is a little Miss Sunshine is standing still and a ramp elevated at 15 degree to the horizontal. So draw the FBD of here. So if she has a mass of 50 kg, calculate all forces. So first process, draw FBD, then calculate gravity. If you can, it's usually a good place to start. Then split any force that is not parallel to x or y into the components along x and y. So sum up all the forces in x. If ax equals 0x, then total force x equals 0. Sum up all the force in y. If ey equals o equals to 0y, so then total force y equals to 0. So now I have here, we are going to draw. So now we are going to draw a elevated triangle. This angle is going right side, so its elevation is 15 angle. So here we are going to write down here, going down the FG, the gravitational or the force gravity going here. So now let us draw here the y axis and x axis. So going to right here is x axis, meaning to say positive. Then going to up or vertical is y axis, meaning to say positive. So now let's find the value of Fg, force gravity. So first we are going to use this formula, equation. Fg, force gravity, equals to mg, mass gravity. So force gravity is equals to, so the number of our mass is 50 kilogram. So here in the problem, 50 kilogram, and our gravitational acceleration is 9.8. So now we are going to multiply, then the result is gravitation, the force gravity is 490, so 490 Newton. So since we have the value of our Fg, so now we can calculate our force gravity in the y-axis. So going down is negative. So now we are going to use this equation. If Fgy, force gravity, y-axis negative because going down negative. So Fg cosine 15. So now we are going to write down here the value of Fg, 490, cosine 15 equals negative 473 Newton. That is the value of our Fgy, force gravity in the y-axis. So this one 400, yes, this is the number of the gravity in the y-axis, 473. So now we are going to find the value of Fgx, force gravity in going here. So from here going here, so we are going to find the value of his force. So now we are going to write this equation. Fgx equals negative mg, so sine 15 degree. So the answer is negative 127 Newton. So this is the value of our Fgx. So now let's find, so we have the value of FGX 127 Newton. So now let's find in x-axis. So let's find the value of our force friction force friction. Here we are going the first value of this point. So we use this equation, y over total force x equals to force friction, then plus force gravity x, because E acceleration equals 0 in x-axis, so total force x equals to 0, so 0 equals force friction plus force gravity x. Then if force friction equals negative force gravity x, so we are going to write down here the F force friction equals, this one is the number of force gx, force gravity x, negative 127 here, negative 127 Newton, so equals 127 newtons. So if friction, so why we are going to write here positive before the negative, now we are going to positive because the direction of the friction is going here, right? So this direction is positive, that's why we are going to write here a positive Newton. So the next we are going to find the value in y axis. So the total force gravity in the total force in y axis equals force normal plus force gravity y. So because E acceleration y is equal to 0, so the total force in y equals to 0, so 0 equals to force normal plus force gravity y. So force normal equals negative force gravity y. So our if for a force normal equals negative, so the value of this one if gy equals negative 473 here, 473 if gy 473 Newton, that's why here 473 Newton. So the result is positive 473 Newton. Our force normal is equals positive 473 Newton. Why? Because our Fn is going up. This axis is positive here. See, y axis positive. That's why. So our the value of our normal force is 473. So we write here 473. This is the answer. So that's all, sir. So thank you.